All right, so in this part of the video, we're going to discuss two very important concepts that we refer to a lot when we talk about functions, that of domain and range. Now you can see the definitions that we have here. For the domain, the set of x values that generate y values, and the range would be the set of y values that are then generated by the x values from the domain. Now, I also have the x values and the y values in quotations. That's because you don't always have to have x's and y's floating around. You can have s's, t's, r's, whatever letters you want. It just so happens most people are familiar with x's and y's. So to be a little more clear, when we say x values, what we really mean would be the independent variable. And when we say y values, what we mean would be the dependent variable. So an independent variable is the variable in which you put a number in. The dependent is what comes out. It depends on what you put in for what came out. So we'll take a look at example 4 here, where you're given a graph, and we're going to figure out what the domain and range would be for this particular graph. So the domain, the set of x values that generate y values. Well, you can clearly see that if this is my x value, it does in fact map down to a y value. Similarly, if this is my x value, it maps down to a y value. And even right here, if I take this x value, does it map down to a y value? Well, absolutely, because this arrow means that the graph actually continues down and out forever in that direction. So in fact, my y value would be somewhere down here. Now, if I come over to this side, that x value doesn't map to a y value on my curve. So when it comes to the set of x values that are going to actually create y values, so the domain of this function would actually be 0 to positive infinity. And notice the closed bracket on the 0, and that's because of the filled in circle right there. Okay? Now, in terms of the range would be the set of y values that are generated by the x values. So you can think of the range more as the up and the down. And if we take a look at our graph, the up and the down would be from negative infinity all the way to 0 with a square bracket or closed bracket on the 0. So all the way from negative infinity way down here all the way up to 0. Our y values have been created by the x values in the domain. Okay, so moving on to the next example, this would be example 5. We'll do essentially the same thing, except we're given some different information and in a different form. Now again, we're going to operate under the assumption that we don't know what this graph looks like. So to figure out the domain and the range, we're going to have to pick pieces apart from this equation and determine what it's going to do consequentially to the overall function. So in terms of the domain, start looking for trouble. A lot of times it's easiest when you're asked to figure out the domain to almost assume it's everything, but really do go looking for trouble. And there's two things that would cause trouble in this problem in terms of the domain. That would be the fact that we have a denominator and the fact that we have an even root. So in this particular case, we know that 3 minus x has to be strictly bigger than 0. It can't equal 0 because it's in a denominator. It certainly can't be less than 0 because it's under an even root. So if we take this simple inequality and solve it, we get 3 bigger than x, which most people like to see it written like this, which is the same thing, and tells us that our x values, our allowable x values, have to be less than 3. So the domain would be negative infinity to 3 with the open bracket on the 3 because we can't have a 0 in our denominator. Now, as far as the range goes, the range would be what happens when you plug these numbers in for x. So this is an interesting one where we don't really care about the preciseness of it, but instead we can see that the numerator is always positive. We also know that from the even root, the denominator is always positive. So when we take a positive divided by a positive, our y is also going to be positive. So the range looks like from 0 to positive infinity. And then we'd want to also make sure that to either include the 0 if y could be 0 or not include it if not. And in this case, based upon having a 2 in the numerator, y will never be 0, so you'll have your open bracket on that, giving us a range of 0 to positive infinity for example 5.